Now let us start a second topic of solid geometry, that is cone. So first see what is meant by cone. A cone is a surface generated by a straight line which passes through a fixed point and satisfies one more condition of type, that it may intersect a given curve or touch a given surface or make a given angle with a line through the fixed point. See your figure. Here it is a cone which is formed, which is a surface generated by the straight line which passes through this curve, passes through this fixed point, and it intersects a given curve. So here in this figure, A is called vertex of the cone, AP it is called generator, and C, this curve, is called the guiding curve. Thus a cone is essentially a set of lines called generator through a given point. Alternatively, the cone is a setup point on its generator. The right circular cone. The right circular cone is again a surface generated by a straight line which passes through a fixed point and makes a constant angle with a fixed line through the fixed point. The fixed point is called vertex. Fixed line through the fixed point is called axis, and the constant angle is called semi-vertical angle of the cone. Definitely every section of right circular cone by any plane perpendicular to its axis will be a circle. Now we have to see equation of right circular cone. First, general form. To find the equation of right circular cone whose vertex is the point alpha beta gamma, vertex के coordinates given है, whose axis is this line, axis ये वाली axis का equation अपने को देने वाला है, and also we have given this semi vertical angle theta. So V be the vertex, VA it is axis, and equation of axis is given by this line. अगर इतना given है, so we can find equation of right circular cone. Therefore the DRS of the axis VA, एक्सिस का इक्वेशन गिवन है, वहां से अपन डायरेक्शन रेशियो निकाल सकते हैं और डायरेक्शन कोसाइन. सो एल एम एन दे आर एक्चुअली द डायरेक्शन रेशियोज. लेट पी एक्स वाई जेड be any point on the cone, then VP is the generator here. Its direction ratio will be x minus alpha, y minus beta, z minus gamma. If theta is semi-vertical angle, so then angle between VA and VP is given by cos theta equal to A1 A2 plus B1 B2 plus C1 C2 upon under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square. आप लोगों को यहाँ कंफ्यूज नहीं होना है. LMN यहाँ पर डायरेक्शन कोसाइन नहीं है, they are the actual direction ratios. So now just cross multiply and squaring. So you will get this required equation of right circular cone. Then standard form. To find the equation of right circular cone whose vertex is origin, axis along z axis, and semi-vertical angle theta. So let Pxyz be any point on the cone whose vertex is origin. So DRS of generator OP, it is here generator OP, will be x minus 0, y minus 0, z minus 0, that is xyz. And you know z axis whose DRS are 0, 0, 1, it is axis of that cone. तो एक्सिस के DRS मालूम है, जनरेटर के DRS मालूम है, दोनों के बीच का एंगल थीटा ले रहे हैं, cos थीटा निकाल सकते हैं अपन, that equal to z upon this, क्रॉस मल्टीप्लाई करके स्क्वेयरिंग करो, so you will get x square plus y square equal to z square tan square theta, which is equation of required right circular cone whose vertex is the origin, axis along z axis, and semi-vertical angle theta. For example, find the equation of right circular cone whose vertex is origin, axis का equation मालूम है, semi-vertical angle मालूम है, DRS of axis निकाल लो. They are 1, 2, 3. Vertex ऑफ कोन is 0, 0, 0. DRS ऑफ जनरेटर निकाले, सेम फार्मूला यूज करना है. On simplifying, we'll get equation of cone. So that equation of right circular cone, vertex मालूम है, axis is parallel to this line and one of its generator having DRS proportional to this. ये result आना चाहिए. तो vertex of right circular cone is this here. Axis is parallel to this line, that is this line. So DRS will be -1, 2, 1. One of the generator is having DR cosine proportional to 1 minus 1, 1. So DRS of one of the generator will be 1 minus 1, 1. P, X, Y, Z be any point on the cone. So DRS of generator निकाल लिए. Again, cone is a right circular. So generator will make a constant angle with the axis. That implies, let us simplify, we'll get this result. On simplifying, we'll get equation of right circular cone. Then next is, prove that the semi-vertical right circular cone admitting sets of three mutually perpendicular generator is tan inverse root 2. Vertex of cone is origin, axis of cone is z-axis suppose, and semi-vertical angle is theta. So equation of cone is this here, but we have given here cone has three mutually perpendicular generator. So we can write a plus b plus c equal to 0, where a, b, c are coefficient of this respectively in the equation of cone, but by the condition that the cone has set of three mutually perpendicular generator. So we can write here 1 plus 1 minus tan square theta equal to 0. Simplify करो इसको, tan theta root 2 आएगा, theta will be equal to tan inverse of root 2. Then find the equation of right circular cone whose vertex is this. Axis makes an equal angle. So since axis makes equal angle, so Pxyz at any point, DRS will be this here. Semi vertical angle 30, cos 30 निकाले. Simplify करोगे तो cone का equation आ जाएगा. Then find the equation of right circular cone generated by revolving a straight line about z-axis. Generating line for the right circular cone is this here. V is vertex. Equation of z-axis is this. Solving 1 and 2, we'll get this result. So vertex is 0, 0, 5. P, X, Y, Z be any point on the cone. Theta is semi-vertical angle. So DRS निकाल सकते हैं. We can find cos theta. Rewriting this equation, DRS of generating line is 0 minus 0 to minus 5. Since the angle between generating line and z-axis is theta, we can find cos theta again by same formula. On simplifying, we get this result. So let me stop right here. Okay, thank you.